All right, you guys are very distracted at the moment, so let's get your focus back. First, the graph. You go up at the third minute, your pace changes. Spencer, let's sit right. At your third minute, the pace changes. So for the first 3 minutes, it's 1 present per minute. One thing that I saw way down here at the bottom corner here, some people did not draw this part of the line segment. All the parts have to be drawn, okay? Next, after 3 minutes of 1 present per minute, then you wrap 3 presents per minute for another 4 minutes. 1 or 2 people did 5 minutes. You got to make sure you only do it for 4 minutes. So that's 3 presents over a minute, 3 presents over a minute, 3 presents over a minute, that's the third time. 3 presents over a minute, that's the fourth time. Spencer. Next one, 2 minutes of no presents. And then 2 presents a minute for 2 presents. Then the next thing you really need to do is find the coordinates of this point. Now the coordinates are not part of the graph, but it's going to help you answer number 2. When you find those coordinates, I find it easier to actually take the point and count to the axes. That way you know you're in line. It's 11, 19. So it was 4 points or 40 points for the graph, and you lost bits and pieces here and there if you didn't get it fully right. A lot of people got it right. Next, what is the average rate of change? Now, I should have shown more work here. Originally, I wasn't going to photocopy this, so I kind of just went through it quickly. Rate of change is slope, which is change in y over change in x, which is y2 minus y1. Now, the last point on the graph is 11, 19. The first point is 0, 0. So if I do the change in y, I'm going to do 19 minus 0 over the change in x, which is 11 minus 0, so I get 19 over 11. Now, number 3 I was a bit picky on. And part of the reason I was a bit picky is because I really truly don't care what you got on today's quiz. The whole point behind the first quiz is to show you what you need to improve upon. What little pieces of the learning do you need to get correct? And what I'm noticing is an old expression, the devil is in the details. That's an old expression about contracts. And it's the subtle little details in the contract that'll get you. And likewise, when it came to graphing this on a number line, I think every single person here drew a number line, they drew a -2, and they drew a 5, and they put a closed circle, and they put an open circle. But not every person connected them. And some of you, if you connected it, it was tough to tell. So I just marked it wrong. I marked it wrong because I don't care, because tomorrow you're not going to get it wrong. You must make it pretty obvious that those are being connected. Because the interval, which is what that notation is called, or this interval, is everything in between. So I need to see that that's shaded, that it's more than just the number line itself with 2 points noted. And last but not least, h of t equals, if you look at the first 3 words, what do the first 3 words say? Anthony?
Write an equation.
Good. Lots of people wrote -16t squared plus 44t plus 24. You never wrote an equation. What does an equation always have in it? Everybody? Equal sign. So h of t equals -16t squared plus 44t plus 24. Anthony, remember the difference with the t. It's not in the exponent. It's in the variable place. Okay?
I know I put in the exponent place.
That's right.
I did not put in the exponent
If-
place, but I said that way you can tell the difference between the plus sign and the t sign.
Ah, do a script t.
Okay.
Now, 1 second, Kaylee. It's extremely important to me that my general impression of your work is that you're getting the gist of it, but the details, little details cost you here and there. Don't let the details cost you tomorrow. Miss Wimmer.
Does it matter which way you put the numbers? Like if you were to put 24 for like instead of 44?
The 44 has to go in front of the t because the 44 is the upward velocity.
Okay.
The upward velocity always goes in front of the t, and the initial height goes at the end. Kaylee, the reason you know the initial height has to go at the end, isn't the starting height wherever the object you're going to throw is at time 0? right? At time 0, you haven't thrown it yet. Agreed? So if you put a 0 in for this negative 16t squared, putting a 0 in for t, and putting a 0 in for 44t, you get 0 plus 0, and that number on the end better be the height it starts at time 0. Otherwise, it's not in the right place. Does that make sense? So the number at the end is always the initial height. All right, now, homework was not checked today, which means it'll be checked tomorrow. All right? Yeah, we just didn't get to it for whatever reason, which is really not a big deal, but we just need to get to it tomorrow. Now, the next thing I want to do is go over last night's homework. And that's here. All right. So let's get out your answers. There's one thing that I know I didn't go over yet. I'm going to mention it to you now. It's very simple. Okay, I want to do maybe 2 or 3 minutes of this homework, and then I want to move into today's lesson. All right, so we look at the top 2. It should be pretty good. Now, notice, of course, that we've done questions like that on these homeworks, and every single time I ever do that diagram, I always show that they're connected in between. Lipstick.
Did we ever get the reflection sheets that we did on Friday?
I do believe this is the only class that got them back. But if not, check with me a little bit later. Yours might still be in here. Okay. Number 15. C is the one that's not a function. And we're going to talk a lot more about this later on. But there is this thing called the vertical line test. Everybody show me by moving your arm which way is vertical. Right? Vertical. That's right. Don't hurt your hand. That's a vertical line test. If you draw a vertical line through the graph, if in any place, it doesn't have to be all places, if in any place it touches more than one time, it's not a function. So if you look, A would touch only once, B would touch only once, but C would touch twice. So C is not a function, okay? Number 16 is 7, 4, and 3. You don't need to write it twice. Yes, Anthony?
And even though for number A, some of the y's are being touched twice, it's still a function because the x must have a different y value.
You need 2 y values for every x value, and the only way that happens is if you touch twice. Okay. Number 17, there are the answers for the range on 17, again, plugging them in. Here we have completing the table, listing them as a function as a set of ordered pairs. This should be pretty easy at this point. The other day we talked about the importance of the negative sign and the order of operations. So I would expect that you did better, maybe not perfect, but better on this set of answers right here. Do I need to discuss any of those?
He has 137, right?
Yes. All right. Do I need to discuss any? Go ahead. B. Let me see what B says. All right, it says negative x squared. My question to you, did you square it first, then negate it? Yeah, that's what you have to do. So you're going to plug in a 5, and if I square 5, what's 5 squared? 5 squared means 5 times 5. What's 5 times 5?
25.
Then negate it, that's negative 25. Add 3, negative 22. Okay? Always, if you see negative x squared, it's square then negate. We went over that pretty hard the other day. Square then negate. Okay, now we get into what we're going to talk about a little more today, the actual graphs and how to graph on your calculator. I know you can't have a square with side 0, but we're just going to kind of work this out as we go along. The area of a square is side times side because the length and the width are the same. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. And then I go out and I plot the points. 0, 0, 1, 1, 2, 4, 3, 9. And then it says, does the graph have a maximum or a minimum? It has a minimum because that's the bottom of the graph right there. Does it have any zeros? Zeros are wherever it crosses the x-axis because y equals 0 when you cross the x-axis. What are the zeros? When x equals 0. Right there is where it crosses. What's the average rate of change? Again, it's going to be 9 minus 0 over 3 minus 0, which is 3. Anthony?
Basically, what I do to find the average rate of change is that I do the rate of a run function from where we begin to where we stop for the rise part.
That's the perfect way to do it.
That's
Perfect.
only for the run part.
Yeah, exactly, but you're beginning and ending on the first point and the last point, and that reflects the concept of average rate of change. Perfect, yes.
On the graph, where's the minimum again?
The minimum is the bottom of the graph. A maximum would be the top of the graph. Okay? The next graph, or the next table, is 10, 4, and 7, and the equation, since you're going down by 3 over 1, it's negative 3x, and then the 0 pairs up with 7, so plus 0. I mean plus 7, sorry. Any questions? All right, so let's get to today's thing, and I have some lessons to put up on the internet, which I will do next period. All right, turn to your lesson sheet for today, and it's not the same do it. And I'm going to work a little backwards today. I'm going to work, don't worry, I'm going to work a little bit backwards on the do it. The one you were given today, okay? What were the lengths of the sides on your particular triangle?
8 and 6.
8 and 6? Okay, good. So, on yours, all right, so this would be 8 and this would be 6. If I want to find the length of the hypotenuse, there's this thing called the Pythagorean theorem. Now, most teachers teach the Pythagorean theorem to say a squared plus b squared is c squared. There is a danger in that. The danger is that you have to remember that c is always the hypotenuse. If you're going to remember that, that's fine, you can always run with it. However, I can tell you every once in a while, they put a question on a test where they put c over here. And then a squared plus b squared does not equal c squared. Okay? So, to avoid that, I like to do this. Leg squared plus leg squared is equal to hypotenuse squared. And these are the legs. And the hypotenuse is always the side that's across from the right angle. So if I play a little bit with the Pythagorean theorem, I'm going to get 8 squared plus 6 squared equals the hypotenuse squared, which is 64 plus 36 is h squared, 100 is h squared. So what number squared is this? Square root both sides, we get 10.
Because what you have to do is that you have to find square root of g squared or 100.
That's right. Okay. So, I know these are not the same questions as on your sheet. What is the first question on your sheet?
What is the... Find the missing side to the right triangle.
We did that. What's next?
There is nothing. There's number 2, well, that's a different triangle.
Oh, okay. What does number 2 say?
Consider the right triangle below. Jen takes her skateboard from the top to the bottom. The height of the ramp is 3 feet above the ground. The length is 15 feet, and it takes 3 seconds
Okay.
from the top to the bottom.
3 feet above the ground, and the length is 15 feet?
Yeah.
All right, so very quickly, 3 squared plus 15 squared is equal to h squared. That's 9 plus 225 is h squared. H is going to be the square root of 234. Can somebody do that, please?
12.
What's the square root of 234?
15.297.
15 point what?
297.
We'll call it 15.3. Okay, so what's the first question in 2A?
Oh, you're asking. Okay. What is Jen's average speed over the 3 seconds?
Okay, so Jen is rolling from here to here, so she's going to cover 15.3 feet in 3 seconds, so it's 5.1 feet per second. That is the path of the skateboard that she rides down the ramp. Next question, does it ask for vertical or horizontal? Vertical. So for vertical, she's only gone 3 feet. Now I know she went a lot further than that on the ramp, but I'm not asking for the ramp's rate of change, I'm asking for the vertical rate of change. So that would be 3 minus 0 over, and again this is vertical, 3 minus 0 over, let's see, this would be a height of 3 and the time is 3, so 3 minus 0. So that's 1 foot per second. And then the next one asks for the horizontal rate of change. right? And that was 15 feet. So I'm gonna get 15 minus 0 over, and it was in 3 seconds, 3 minus 0, which is 15 feet per second.
5
What's that?
5 feet a second.
5 feet per second. I wrote 5 instead of 15. Now, here's the really cool thing. Not only does the Pythagorean theorem work for the distances, it also works for speeds. Check it out. On your calculator, do this. 5 squared plus 1 squared equals 5.1 squared. And it's going to be slightly off because we rounded off, but check it out. Do 5 squared plus 1 squared, hit enter. And then do 5.1 squared, hit enter. And you're going to see that they're pretty much exactly the same. The only thing that's off a little bit is the fact that we rounded off before. Had we not rounded off, it would be perfect.
I'm sorry.
Do 5 squared plus 1 squared, get that answer. That's going to work out to be 26. Okay? And then do 5.1 squared,
26.01.
26.01. So the only reason for the slight offness of 0.01 is because we rounded earlier. But my point to you is that's something pretty neat to me about the Pythagorean theorem. It doesn't only work with distances. It works with speeds. It works with anything in the triangular shape. Okay, so graphing. What is the graph that you have on your paper?
There's actually 2 of them.
All right, well, what's the first one?
Y equals X.
Y equals x squared plus 2.
No, it's x. No, it's x
Plus
squared,
2x
Squared plus
x squared plus 2.
That's what we said.
plus 2x minus 8.
No, it's just 2x.
Oh, just 2x. Okay.
Alright.
So, go to your calculator.
Or just 2.
Wait, no,
No,
it's just 2.
Oh, just 2.
X squared, no.
Okay, so y equals x squared plus 2. I have no idea why this is taking so long to write up on the screen, but whatever.
It's like magic.
Yeah, go to your calculator. Go to y equals. Okay?
Where?
Y equals is in the upper left-hand corner. Now, go to, you see where everything should be cleared out, assuming it is. Remember the variable button that says xt theta n?
Yeah.
Hit that button, then squared, then plus 2.
Wait,
Sorry, I don't know how to.
Over here somewhere, there will be a xt theta n button. Hit that button, and then hit squared, which is on the left side, and then plus 2.
Plus.
Okay, guys, everybody quiet, listen carefully. You will be an expert at this very shortly. That's not exactly what I would call this. You have y equals. Then you need the button that looks like this. X, T, theta, n. That button is usually toward the upper left. Now, hit the squared button, which is on the left-hand side of your calculator running down, and then hit plus 2. And then hit graph. Now, if your graph, it should look like a perfect graph.
no, it says,
It's a quadratic.
error invalid DIM range.
Okay, listen, stop. Here's the problem. If every person's gonna talk, I cannot answer all of your questions at once. Here is a real, listen, Kristen, stop. This is a really cool trick that will solve most graphing issues. If you're having an issue with your calculator, even if you're not, just do this. There's a button that says zoom. It's toward the top. Hit zoom 6. And then hit graph again.
Worked.
Yes, what that does is it resets what coordinates it's going to put on it. When you graph it, now here's the thing about graphing a quadratic. You ready? What a lot of kids will do is like a cartoon from when you were a little kid. They will look and go like some kind of artist, and they'll go, close enough, and they'll just sketch something. No. Now I want you to look. See how right above the word graph, for the graphing button, there's the word table? Go to second graph, which is second table.
So should we be on the graphing screen?
You should be on second table.
I don't have a table.
Oh my.
Now, that gives you the coordinates, Mr. Dessing, of every single point on the graph. So I'm going to go -3, -2, -1, 0, 1, 2, 3. And then I'm going to look at, that's the x or input value, there's the y value. Then it's going to go 11, 6, 3, 2, 3, 6, 11. And when I actually go to graph a parabola, I don't just sketch the picture, I plot these points. -3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. -2, 2, 4, 6. -1, 3, 0, 2, 3, 6 here. And there's my graph. Okay? So the way you use the graphing calculator is you go to the y = button, you put in the function using that xt theta n button, we call it the variable button, and then we hit graph, but we don't graph it based on the picture that comes up because it's going to be a little sloppy. We go to table and we plot the points in the table. Okay, what's the next function on your paper that it wants you to graph?
Y equals -2, no, y equals -x squared plus
Plus
4.
4. Go to y equals, clear out what you have in there, and type that in. When you just type it in and look at what your calculator prints. Don't worry about graphing it. It should look like this.
Patrick Egan and Anastasia Bove Eckert, please come to the main
Okay.
office.
Right? Upside down? In there. All right. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. I get the saying. Adios, amigos y amigas. Cheerio. Toodaloo. Ta-ta. Garusharus. Kadafis. Sayonara.
Rachel Marrero, to the guidance office, please. Rachel Marrero.